So, hello everyone and welcome to another Frivolous Gravitas training video on some JavaScript programming. This is a no experience required session, so like our other one with primitive recursion, which I strongly recommend you check out, obviously with a little bit of bias intent. This time we're just going to be looking at functions and the different ways and equivalent ways of rewriting the same types of code. And this is sort of just to get a foundation. It's not intended to be best practices or guidelines or anything like that. It's basically just to get you started without having to install any software or set anything up from the ground up. So we'll be using JavaScript in the browser for that, because everybody's got a browser set up, and dive right in. So I'm just going to find a folder, and I'm going to create a new file by right-clicking anywhere in the background of the folder. Under Windows, that'll be under New, and it'll be New Document, and I'm just going to call this functions.htm. And again, it's really important to put that .htm or .html, because that's what's going to tell our browser that we are working with a web page. I'm using Sublime Text for the purpose of this session, so I'm going to open that up right there. And it's a free tool. It'll ask you to download once every 100 times you save it or whatever, or to pay for it, I mean, once every 100 times you save it, but you don't ever have to pay for it. It's just, if you can afford to support the developer and you like the tool, please do. So strongly recommend that. And for a browser, I'm just going to open up Chrome. New window. And I'm going to take that file we just created, the .htm, and I'm going to drag it into my browser. And I'm going to drag this into my text editor. So now both of these programs, I can get rid of that, are using the exact same file. So what we're going to be doing is we're going to write something on this side over here, and then we'll be displaying it on this side over here. Let me just resize this a bit. Now to start off, HTML just needs some quick boilerplate, or in other words, just common code that goes in just to tell the page how to display. And I'm not going to make you watch me type that all out, so I've got it a little bit of a template here already set up. But as you can see, it's pretty straightforward. We're just creating a basic web page with HTML tags, opening and closing tags, and everything that you want inside of those tags. Let me make this a little bit bigger for you. Oop. There, now you can actually read it. Everything between the opening and closing tags is a child element, they call it, of its parent. So as you can see, inside the head we have a title and author, some metadata. You don't actually need any of this. What's really important is just the doc type there, and you want to have a head. That would be this and this. Opening and closing tags, the slash makes the closing tag, and a body. And then you just close the HTML after that. And again, the reason why we're going to be using the browser is because we've got a built-in JavaScript engine, interpreter, compiler, whatever you want to call it. The thing that reads our code and spits out information. We're going to write all of our code in JavaScript here and give us some room here. And the reason for that is, like I said, we don't need to install anything or set anything up. It's just straightforward. Now, I'm going to copy in some comments here just for the sake of brevity. So what I'm going to be doing is Control S on this page over here to save the changes, and then Alt Tab to switch over to here, my window for my browser. And then I can Control R to refresh the browser, and you'll notice this is being updated with this tag up here, so I know that my browser is now reading the same page as my text editor. And you can switch back and forth, or you can click, whichever. The refresh button up here does the same thing, and I believe F5 does the same thing as well. So with that, we'll get started. We don't want to make this as exhaustive as the last one on primitive recursion, because we went through a lot of standard, just basic functionality of how to set up and work with everything. But as you can see, it's really quick. I just made a new file, opened a browser, opened my text editor, and drag the file into both of those, and hit save, and we're good to go. So let's start working with functions. What is a function? When I started programming, I was reading textbooks and tutorials and everything, and there are great resources online for more detailed, in-depth look at the actual jargon and programmatic functions of functions. But I find that they were very complicated in the sense that they never really described what I was trying to do with them. So basically in this video, I just want to show you how to practice with what you learn so that you can learn bits and pieces and put them together and manipulate them a bit and sort of get a feel for how programming works by figuring out what you can and can't do as far as flexibility goes with writing code. And that way you can give yourself little challenges to practice on. And every little new bit of information that you pick up, you can basically extend that to your practice, rather than just following tutorials and being told what to do and then having somebody else set out your goals or aims or objectives. You can create goals and challenges for yourself based on what you know. And functions are a great place to get started with that. So the code that we're writing today isn't going to be useful code. It's going to be code that helps you learn how to code. It's useful in the sense that it teaches you how to practice and manipulate what you do know and how to find things that you don't. So to start off, let's just grab our body tag so that we have something to attach things to later on. And I'm going to use by tag name, and that returns a collection, so it's always going to be the first index in the collection because we only have one body tag. This document.getElements by tag name is a built-in function of JavaScript. It's technically actually a method of the document object, and the document object's built into JavaScript. You'll be using this a lot, so we don't really need to go over it. The more you see it, the more familiar it'll be, and that's sort of the point of the practice, right? But maybe we'll get into the document window objects a little bit later, actually. So let's start off. What do we know? We know console.log. We used that one a lot before. So console.log is what's going to tell us how to open this stuff in here. And the console, if you remember, is just, you can open it up by hitting the settings. Yeah, there it is. So you can change it. You can have it dock separately on the right side. You can have it dock on the left side, etc. This is going to be where we spit out our code every time we type console.log. And every time we type console.log, what we're going to be doing is checking that our code is doing what we asked it to do. So it's kind of like a logic test. So we use it a lot when we're playing around and practicing. But the benefit to it, as we'll get to, is it actually shows the breakdown structures of all your variables. So whether it's an element or a data type, or if it's got or an array data type or an object data type, or if it's just a variable with a value, or if it's a function, you can use anything with console.log and it'll tell you exactly what you're looking at. So I control S on this side, Alt tab over, control R to refresh. Shows undefined. Why is my body undefined? Get elements by tag name. That's why. By tag name. So control S, Alt tab over, control R, and there we go. We found our use for console.log already. We found a typo in my code. So as you can see in the console, it actually gives you a breakdown of everything that's in the body tag that's being rendered from all this stuff I put up here, which is the reason I left it there, was just to give us something to look at. Everything with the double slash in front is a comment. That means it's used for the programmer to read to help us follow along with what we're doing without the code trying to be read and interpreted by the JavaScript engine itself. So again, if I hit Control S, Alt tab over, and Control R, you'll see this is gone because I put the double slash in front, which means don't read this. Basically, it's just for our own use. So you'll be seeing me use comments a lot, and in the real world, actually, it's really good practice to use comments too, so that anybody can read through your code and figure out what's going on. So there are a few ways to write functions. Let's say we'll start with the function keyword. This is a built-in with JavaScript, and we used it a lot before in our recursive episode. which is our first tutorial in JavaScript. So I won't go too much in depth, but I'm just going to show you a few equivalents so that you get the basic idea of what we're doing. So test example 1, let's call it. The opening and closing parentheses are required for every function, and that's because functions need to be executed, and if you just left it as a variable name, it would just act like a regular variable and think that it has its own value, whereas this interprets this variable to have actions in it, and the actions are enclosed in these opening and closing curly braces. The indent, just to help us read the code to know that all of our code that's indented is within its parent. So every time that you go one level deeper in a nest, they call them being nested. Also, they call it parent and child elements, that type of thing. Basically, what we're talking about here is just the scope. So everything within these curly braces are within the scope of this function that we're about to define. So our test example 1 is just going to console.log to show that it works. This is test example 1. And then if we Control S to save, Alt Tab to our browser, and then Control R, oops, there we go. Oh, and notice how it didn't do anything, and that's because we just defined it. What we actually have to do is call it. So now that we have it defined, we say test example 1, opening and closing curly parentheses, tells us to execute the code and says, well, what's the code? It looks under its definition. Everything between these curly braces is part of its definition, and then it does the console.log. This is example 1. So Control S to save, Alt Tab over, and Control R. So Control R refreshes the browser. Now it's going to read from the newly saved file. I'm going to just switch back and forth and do this really quickly because you don't need to hear me keep saying Control S, Control Alt Tab, Control R, but just as a reminder, that's what I'm doing, so that's why I'm sort of repeating it over and over again at the beginning, because it might be confusing to just see me switch around and your code's not updating as quickly as mine. It's just because I'm using shortcuts. Now, the neat thing with JavaScript is it's sort of an old language, so it's evolved a lot, so there are new ways now that you can write functions. So another way of writing a function is by using let's use text example 2. We'll just make it easy. By using variables and then an anonymous function. This is a function that has no name. So you notice I'm using the function keyword, but I'm not giving a name in front of it. What I'm doing is I'm saying let this variable equal a function, which is exactly the same thing as telling a function what's the variable name and then defining it afterwards. So it's just another way of writing the same code, and you'll see how these are useful later. But actually, I'm just going to copy and paste for the sake of brevity, and then we'll call that example 2. Control S, Alt Tab, Control R, nothing happens. Test example 2, open and closing parentheses. There we go. So with that, there is one other way I want to show you how to make functions, and I'm going to use these interchangeably in this episode because this is sort of the point of this episode, is to teach us how to use functions, and the first way to do that is to recognize functions when we see them. So this is called a fat arrow function. It's just the equal sign with the greater than sign, and you can use the parentheses in front of it. If you only have one variable, you don't necessarily need to use the parentheses, but I'm going to leave them there just to make it easier to see everything. Yeah, and I'm going to... This is example 3 of fat arrow functions. And you will notice test example 3, and this is the benefit of these text editors, by the way, that predictive text that kind of shows me or helps me figure out. See, it notices that I've got these 3 functions already defined, so you can just pick one instead of having to type everything out. It's the benefit of using a text editor that's not, I mean, you can do all this in Notepad, but it's not going to give you the color coordination like this does to show you, or these little underlines that show you where your opening and closing parentheses are, or curly braces are. It does it with parentheses too, actually. So if you had a parentheses that was split up, it'll tell you the opening and closing there too. So it's handy to know the different ways that we can write functions because we're going to be using them a lot. So just keep all this in mind here. Function, variable name, parentheses, parentheses, parentheses. You'll notice that every time we have a function, the parentheses opening and closing are necessary because that's what tells it to call it. The function keyword is helpful for readability, but it's not necessary in the new type of JavaScript. You can just use this syntax here. The way of typing things or wording things, the way the programming language expects them, that's just called syntax. And so yeah, I'm going to leave all this here, but I'm going to comment it out for now, because we're going to move on and start getting a little bit more fancy. So how do we practice with functions? To get a sense for how they work, the best way to do it is to just give yourself a little task. And knowing that we can create functions now, it's just a console.log in them, let's try creating functions that create functions inside of them, just to get used to nesting hierarchies of programming. So I'm going to start by making a function that's going to get called when we load a page. And when we load the page, we'll use a built-in window. Is just like document. It's a built-in object that's just part of the browser, the way browsers pull up and interpret and read code. And I'm going to just use an anonymous function this time to help us get used to all the differences. Remember, this is a built-in method that says when the page is loaded, do this. So we haven't defined this. This is predefined for us. But what we're going to do is tell it to do something when this is triggered, and when the page is loaded, like when I hit refresh, that's what this does. When everything's loaded, call this function. We didn't give it a name. That means it's just going to execute right away. It's not saving our definition to be called later. It's as soon as it's called, this is what this means or equals. So let's start just by a quick console.log to make sure window is loaded. Control S, Alt Tab, Control R. You'll see window is loaded. Line 22. That's where we called it. So good. Our load function is working, and that's a built-in. Now that we've got a load function working, we can use this to call when page loaded. And you'll remember that this is our defined function, but we haven't actually put anything in there, so it won't do anything when it called. But it won't return an error either, because if we didn't have this defined, it would say when we try to call this, hey, I don't know this variable, and the whole thing wouldn't work. You get an error like this, reference error. So coming back, if I uncomment that, save it and come back, you'll notice that it just doesn't do anything because we haven't told it to, but at least it doesn't choke or crack or crash or anything like that. So let's define a function inside of another function just to get used to this nesting a bit. I'm going to actually give this one some parameters too to help us look at different ways of using functions. So this A and B can be whatever you want. You can call it AA or BB, BNN, whatever. What we're doing here is we're saying inside of our function definition, inside of these curly braces, every time this function name is called, we're going to be expecting two pieces of information in it. So maybe we'll start again with our console.log. Yeah, that makes sense. Oops. Function is being called. So now everything within this and this is the same as using double quotations, but you can't mix and match them. So if you're going to use double quotations, they both have to be double quotations or it'll choke. And that's so that we can use, obviously, we can use the apostrophe if we need it. But if you don't need it, you can just use single ticks, that's fine too. Now when I save it and load it, Windows is loaded, all good to go. Notice this didn't call, and why? Because we didn't call this function, we just defined it. So when I save this and go over here and then refresh it, it doesn't have anything to write out because we didn't tell it to act. That's what we mean by a call. When you call a function, what you're doing is you're telling it to run the code that's inside of it. You can also refer to a function, and that's when you would drop the parentheses. If you were just going to refer to the function, you'd write console.log, log first function. If you just refer to it as a variable, it's going to consider, it's not going to call itself, it's just going to return what's actually in the variable. So when we go back over to our browser window, oh, we got to call it first. First function call. You'll notice that it actually gives us all of the code that we put inside of that function rather than executing the function and giving us a result value. So another example to this might be, well, let's just make another quick log here so you get a better idea of what's going on. I'm going to use a template literal, and that's on the top left of your keyboard just under the escape key. You can find these single ticks, or back ticks, they call them, or many people call them. I'm going to use this because I'm going to show you a way of displaying the variables inside of your code in an inline format so that you don't need to, and I'll do it the other way too actually, console.log. I'll make another equivalent way, and this is just the regular apostrophe. Maybe to make it clear I'll use the double quotes. So the value of the, so the second parameter is, so the alternate way of doing it is to add strings together. So this is a string, everything between the quotation marks. I use the plus sign to add two things together, and then I just use the variable b. So what I'm doing in here is, you notice I didn't have to break out the string into two different pieces because I use this backtick, and again that's the key just under the escape key on the top left. So it's not an apostrophe, it's actually a backtick. But you have to use this notation, and that's called a string template literal. No need to technically remember the jargon for it, but just so you know, if you ever do want to make something, a simple console.log that just tells you your variable, but you've got a whole bunch of logs in here, the best way to do that is just to do an inline template variable, but it's equivalent to saying plus b. Now when I call this first function, in order for it to give us something to spit out, we have to give it some values. So I'm going to just say test value 1 is my first value, and you separate values with a comma, just like we did up here. So now test value 1, when this is called, is going to be in A. So this function says, I don't know what's going to be given to me, but I know something's going to be given to me, and that's something I wanted to display. So this will be test value A because it's in the first position of the called function. And B will say value B. So I'll save it, Alt-Tab, Control-R, and now you'll notice this function's kind of annoying, so I'm going to get rid of that console.log because it's taking up room. So the value of the first parameter is test value 1, the value of the second parameter is just value B. And you'll notice that's precisely what we put in here. And as we change these, so too will our code update. And now you're sort of getting the idea of how functions are useful, because we can use these when we don't know an input that's going to be entered in, but we do know that we want to display it. So this is great for data logging and things like that, or if you're working with tables or graphs or charts or anything like that. This type of notation where you separate the input values by a comma and then you display them afterwards without actually knowing the value beforehand, but you can define a function with variables and expect those values to be passed in. That's crucial to what we're going to be doing working with our functions today. Another point of note is the return is a keyword. You'll notice it highlights in red here when I use, because I'm using Sublime Text, and Sublime Text knows HTML and JavaScript. So checking out the colors of the words that you type also helps you find, typos. See, if I just write return, but I write it wrong without the U, it doesn't turn up in yellow. So I'm going to save that. So what I'm doing in here is saying I'm going to return A and B when I call the function, but you'll notice A and B are defined in this function up here. So if I call it outside of these curly braces, it's going to be expecting an A and B from this function up here, but we haven't defined anything in this function. So I'm going to move that in here. And that's why we keep indenting things, is so that we can keep our return statements separate, because this one is not the same as this one. This one's going to return from this function. This one's going to return from this function because one is nested inside of the other. So with JavaScript, it's nice because you don't actually have to work with, you don't have to worry about the spacing or the look of your code or anything like that. It'll still run properly, but the visual cues like indentation and stuff is just really helpful for the people programming, the coder, you and I. So we're going to write another function here, call it second function because that's how original we are. And I'm going to call log. What are we going to do with this one? Second function is being called. That's what we do. And we're going to start working with some variables. So we're going to say x equals fn. Now, this function is expecting another variable that we're going to call fn. This could be, again, anything you want, but you can't have spaces because variable names can't have spaces in them. So if you want a space, you'd have to use an underscore, and if you want multiple values, you have to use a comma. But just for simplicity's sake, I'm going to call this fn because in this function, we're going to pass a function into this function when we call it. Now, it sounds complicated, and it is, but it's useful and it's fun to practice it. So I'm going to say that let x means define the variable x to be equal to whatever we give this. So right now this could be a number, it could be text, could be anything. But I know that I want to put a function in it, so I'm going to give it a name like fn just because that represents the word function to me, so it helps me read the code better and know what I'm doing. So now x is a function when I pass in a function to it. So I'm going to have to use the open and closing parentheses to call it. And that means to execute the code that's defined inside of the function. So I'm going to say value 1 and value 2, for example. So what happens here when we call our second function? Well, our second function is going to require a function inside of it. What function should we give it? Actually, you know what? Let's call these answer. So answer1 equals. We'll start with the first function then. First function, we'll just give it two strings, the letter A, the letter B. That one's nice and easy because we did it already. The second function, we're going to pass in the first function. That way we can see them back to back here. So remember, this answer is going to be the return value of the name of this function's name, which is up here. And it's going to be passed in the values a and b, which are actually going to be named variable a and b. And again, don't be confused. These are not the same. They're not equivalent. This is a text. This is a string. It's in quotation marks, and that's why the colors are different. And this is a variable representing anything that we put into this. So we could also, just for fun's sake, use 5 and 4. And again, 5 in quotation marks is not a number. It's actually the string value, the text value of the number 5. Whereas this 4, the reason why it's a different color is because that's actually a number type value. And the number value is going to be able to add, multiply, subtract, like do math on. Whereas the text value will give you a number, but it's going to give you a number representation as like the code value for the character of the number 5. So it's important to, that's sort of why I'm repeating this over and over again, is so that you can make sure that you're checking for quotation marks and non-quotation marks where applicable and knowing why you're doing it. That's really important too. So our window function is going to load, and then it's going to call when page loaded. When page loaded is going to give us this function here. So maybe I should put this stuff inside of it. We'll see how this goes. So part of the fun is just trial and error and seeing how things work. Yeah, see, this won't work and it's not defined because when I call this when page is loaded here, it opens up this function here, which is where we defined our first function. But the problem is this function is only defined inside of this variable, or this function, I mean. So when I try to call this one, I have to call it from inside of this function here, otherwise it can't see it. So this one here, yeah. You'll notice I'm calling this from outside of this this block here. So maybe for simplicity's sake for now, I'm going to cut and paste this so it's all within the same scope. There we go. There. That'll allow me to actually call all this. And maybe I'll put this inside of our when page loaded so that these variables, these variables get defined when the page is loaded. So you'll see when the window is loaded, our anonymous function just runs this code. It says page is loaded, then when page loaded. That's a variable name that we chose. This tells it to execute it or call it. So when page is called, we create two variables. The first variable equals the output of this function here, which is first function AB. All it does is console log A and B, but then it returns the addition of A and B together. So what I'm saying is answer 1 equals the return value of the function that we're calling. So that's going to say the text 5 plus the number 4, which isn't going to do our math for us, but that's sort of the point of showing you the importance of knowing your data types or what type of values you're entering into your functions. So let's follow through. Window is loaded. That's our console.log here. First function is being called. That's our console statement here. You'll notice the line numbers are all printed on the outside too to help you out. The value of the first parameter is 5, value of the second parameter is 4. They look the same, right? But when we, I should actually, guess we console.log our answer so that we can actually see what we're doing. Or see what the output is, rather. So answer 1 and answer 2. So I want to console log this and this to see if our code's doing what we expect it to. So Control S, Alt Tab over, Control R. You'll notice now the value of the first parameter is value 1, value 2. That's 18 and 19, these two lines here. That's our string template literal, and this is just concatenating or adding to a string together with the value that we got inputted in our first function, which is what we call here. First function, the text value of 5 and the number 4. It returns us a text value of 5 and 4 together, so it's not actually 54. But you'll notice if I take these quotes out, save it, and reload it, it actually does the math. Now it's 5 plus 4 in here. So it's very important to note the difference between quotations and non-quotations, because they're different data types. One's a number, one's a string. The other data types available to us are functions, objects, arrays, Boolean values. Yeah, so JavaScript's neat for that because you can kind of throw anything you want in it. But the other important section here is our function, second function here. This is interesting because what we're saying is answer 2 equals second function, and then we're putting the first function inside of it, but without calling it. And that's really important because what we're doing here is we're passing the entire function in here, and we can even assign it to another variable if we want, and then we can call that function just by using the opening and closing parentheses again. And what does function 1 do? Well, it takes in, or first function do, it takes in two values and gives them a variable A and B, and then it does its processing and returns whatever it wants to return, right? So in here, because I've made x equal to the function that we put in, this fn is only valid within this block scope here of these two curly braces, and that's passing in the whole function without calling it, just the function variable. And then we're calling it when we call x with the opening and closing parentheses, and then we can give it its two values, just the same as if we had called it directly with its own name. It's just, again, not very useful for this example, but what we're doing is just showing you how you can manipulate things and rename them or rework them or reorder them, because that's the thought process that's really helpful when learning programming. And I find most tutorials tell you the academics really well and the theory really well and the best practices really well. but they're usually too structured and guided for me to easily learn how to just alter code for myself and play with it. And that's the best way to get an idea of what's going on with your code, is to actually just play with it and stick new values in and see what you can and can't do with it. So let's write a third function then. And maybe we'll do this one a little bit differently. Let's use a const this time. Const just means constant. It's another way of declaring a variable. There's var, which is deprecated. That's the old way of doing it. You used to say var x is equal to 6, just to define it. If we don't use a keyword before it, it'll still work, but what it does is it puts all of your variables into the global scope. That means everything in here, and it gives you an opportunity to reuse a variable by accident, and that's generally not what we're looking for. So, const, that's what we're doing. So const, let's call it just third function so it's easier to follow. And we'll give it a few values, and notice that we're reusing the same, we're going to reuse the A, B, and C, but because these are strictly inside of our function definition, they're not going to overlap or conflict with these other ones. So it's just important to keep in mind, so I'm going to keep doing this to sort of make it look confusing, but for a practical reason, to help us juggle our variables and stuff. I just realized that there you go. Now you can actually see me gesticulate. Sorry about that. I'm just getting used to these new streaming platforms and yada yada yada. So let's do a console.log, and we're going to say this is our third function. Again, this is in text because I've got quotation marks, so it's not actually going to call it, even though I've wrote this function out and put the parentheses in it. Just helping you sort of get an idea and a visual and see it in practice so that your brain can kind of keep being reminded of what we're actually doing. And I'm just going to use A and B. So what I'm doing in this third function is the same as we did in the second function. I'm expecting C to be a function, and that's why I'm calling it here. And the return says that the output of this, when I call it, ultimately, after I do whatever instructions I want, do a bunch of instructions. In the end, after it does all your processing and calculation and adding things and subtracting things, it outputs a return value, and that's why you see one return statement usually in every function. They don't have to have a return function if all they're doing is manipulating things, but yeah. So now when we call this third function, we're going to need to give it two values separated by commas, and then a third value separated by a comma that's actually not a value but a function. So to do that, let's just go back up here to, where's answers? Boom. So let answer 3 equal third function. And what are we going to use for values this time? A is what it's going to be. Let's just say we'll use number, 5, and then function. Which function are we going to give it? First function, I guess? Yeah, let's do that. First function. And again, you'll notice I don't use the parentheses because I don't want to call this function. I just want to pass it in to whatever C is here. And then C is going to call it as part of its return, and C is going to give whatever we gave as a first value and whatever we gave as a second value into whatever function we gave it as C. So the function we gave it is defined as, you can see it gets a little bit complicated, but first function, and first function takes two values, and then it console logs them, and then it returns A plus B. So let's actually console log this. Oh no, we can actually do that after. Haha. Let's just call this one temp, because I don't think I'm going to keep it. I just want to see that our code actually works. So third function. Oh, we actually already did it up there. Never mind. You just got to take this, copy, paste, and change it to 3, and it should log it out for us. Okay, so we're looking for line 29, and that's right at the bottom here. Cool. So you notice we got our 5, the number that we put in, and the string 5 from here. So 5 is input as a number, but then it converts it to a string because numbers and strings can't come together. So primarily you've got a Boolean, so that's true or false. 1 equals true, 0 equals false. So you can convert any number into a true or false. But if you want a number higher than 1 and you want to process it as like a mathematical equation or something like that, it sort of steps up the data type from Boolean value, the true or false, to numeric value, and then you can process calculations like multiplication, division, modulo, that kind of thing. But as soon as you add quotation marks, and you create a string out of it, and a string has its own methods and functions attached to it, but then you can't do math with it after you do that. This is one of those things where JavaScript is helpful with, but it's also a detriment because it'll mutate the value of your or the data type of your variable as you use it. And most other programming languages will throw an error. They want you to define whether it's going to be an integer or a floating point number, or they want you to tell whatever it's going to be right up front. But JavaScript is very flexible that way. We can just keep repurposing and changing the value as we go along, which is nice. But it also leads to pitfalls and traps, which you can obviously imagine, but that's going to help us figure out all of the, the fun things that we can do with JavaScript too, because that's what gives it its flexibility. What else? Let's start using the window functions a little more, because there are some built-ins that are extremely useful just for playing around and practicing, and timeout is one of those built-in functions that's useful. So I'm going to attach that to our window object. I'm going to create a set timeout, and the reason we're doing this in the functions tutorial is because timeout functions take a function as a value, just like we did in here. And just for the sake of brevity, I'm going to use our fat arrow function, which is just, again, an anonymous function. It's the same as just, where else did we do that? Here. Nope. Yeah. So function here without a name, it's just an anonymous function. That means it gets called immediately. It doesn't store the thing to be called later. It doesn't store the instructions to be called later. It just gets executed immediately. The set timeout is going to take a function. It's going to say, after 1500 milliseconds, the second after the comma here is the second parameter that gets put into the set timeout function, which is contained within these two parentheses. This function is going to run after this time goes out. That's all this function does, the set timeout, and you can apply it to almost anything. So just to make it a little bit more readable, I'm going to space it out. And you'll see that it automatically indents for me. That's just part of the sublimeness of Sublime Text, or any other text editor will do, coding text editor, that is. But Notepad and stuff like that, as I said before, gedit, or they don't automatically organize your code for you. You can also turn that off if you want, but I find it really helpful. Like I said, it helps with readability and all that. Now, what kind of function are we going to put in here? We'll just say console.log our timeout function has fired, just so we can see that it's actually working. Oops. Here we go. And then you notice after 1.5 seconds, which is 1500 milliseconds, fires. If you want to see it again just to make sure. Oh, popped up. So that's a timeout function, and those are useful because now you can play around with timings of your code. So if you want a certain bit of code to wait until something else loads and then run, set timeout is one way of doing it, but we can also play with it with our own code here. So maybe I should show you hoisting first. When you create a function and you write it down into your text editor and you save everything, you go to your page and then you reload it. It goes through all of your instructions sequentially, but before it does anything, it saves all of your variables and functions into memory so that it can run them later. And this can sometimes be confusing to people when they're first starting out, because it was to me anyway. They don't really understand why their functions are able to be called before they're declared. Whereas when you try and run a variable, let's just say console.log y, and then let y. So you notice I define the variable after I'm calling it, and the browser's not going to like that because it says a reference error cannot access y before initialization. Initialization is just the programming terminology for being defined. But you'll notice if I take this, the console log, and put it in after I've declared it, then it has no problem at all. It just says undefined because we haven't said y equals anything, right? We just said let y, so create a space in memory that's called y. So it's there, it's not going to return an error, but it doesn't know what's in it, so it just returns undefined. So with that in mind, you'd think the same kind of action would work with hoisting, but it does not, or with functions I mean, but it does not, and that's because of a built-in part of the compiler or the engine, the JavaScript engine, tells it to save all the variable names that are functions first before running any of the code on the page. There's probably a really good reason for it, but I'm not sure exactly what it is, to be completely honest. But, well, let's just start with an example. What's our example going to be? Another console.log, I guess. I'm getting a whole bunch of these, but this is an example of hoisting. Actually, let's use this inside of our window. Yeah, because we have a timeout here that's not doing anything. Our window.timeout, when page loaded, just loads as soon as the page is loaded. So let's throw it in here. And hoisting example. And we use the parentheses to call it. We don't need any parameters, aka arguments, in here, because all it's doing is a console log. It doesn't use any inputs from us. So save that and refresh. See, the timeout runs, and then an example of hoisting. Now you'd think if everything ran in order from page top to bottom that I couldn't call this function when I'm defining it down here, because remember when we did the variable y, I had to declare it before we were able to use it. But just keep in mind, the reason why is called hoisting, so if you want to learn more about that, you can look it up, and at least now you have the word for it, you know what you're looking up. Let's try some new types of functions. So let's action, because functions are always actions, it's helpful to remember. We're going to use an anonymous function again, just as a different way, and remember these are all the same. Where did I write that? Oh, I guess I erased it. Anyway, there are three ways of making functions. You can use the fat arrow, a variable declaration with just the an anonymous function, or you can use the keyword function, the name, parentheses, open and closing curly braces. They're all the same way of defining a function, so I'm just going to use them interchangeably just to help you practice, get used to it. Let's x equals a default string value. Now, using this x equals inside of my parentheses would be the same as using this inside of a parentheses and then defining this as, you know, default value of C. That's sort of the same thing. So you can see why it's neat to just play around with your code to see what you can and can't do. Putting an equal sign inside of the arguments for a function will let you give it a default so that if it's called and here's an example. If this was called without giving it any answer for A and B, if I put an equals value in this first function up here for a default value, then even if it got nothing and it just got empty parentheses, it would just pick up the default value instead of what you put in. But whatever you put in overrides the default value. So that's important to note because often you'll want some type of default value so that when you try and read this variable, it doesn't give you an error if somebody accidentally calls the function without, or if you accidentally call the function without defining anything. So let's just make this one simple, return x. And I'm going to show you how to get used to reading code in different ways, even that it does all the same thing. JavaScript's going to ignore our spaces, so this and this and this is just for readability. You can get rid of them if you want, you can keep it if you want. Notice that anything within the curly braces is part of our function. Even if it's not on a separate line, it's still part of our function. So you can define a function the same way as you define a variable, by using the function keyword as what it equals, and then have it return whatever you give it. So now when I call SumAction, actually let's make another variable here. Let's say action equals SumAction. And then SumAction, remember, is a function, because I told this variable to equal a function. And what's the function equal? Well, it can take one argument or one parameter, and it's just going to spit out the answer. And if I don't give it anything, it's just going to say default string value. So that's sort of the way it's written, the syntactical sugar to it. I'm just going to call SumAction with it. Let's put a non-default value for the SumAction function. Oh yeah, see, I keep forgetting to console log this. Console log action. That's part of the practice of code too. You just sort of get used to making mistakes, reading errors, figuring out what's going on. Where's our... We're looking for line 55. Maybe I gotta clean some of this up. Oh, here it is. Right at the top. Default non-value for the SumAction function. And again, if I write SumAction Control C, Control V, Control V. If I write SumAction and don't give it any variables or any input values inside of the function call, then it's just going to return the default value. And our default value of x, because we're telling it to just return x, whatever x is, our default string value is what's going to show up. And you'll see the non-default value is from the first time we called it, because the action variable is actually equal to the action function with this value specifically in it. Whereas the SumAction function is, it either takes a value or it takes nothing and just outputs the default. So the second time we called it, it just output the default because I didn't give it any parameters or arguments to process. So I'm going to clean up some of our code here just because our console is getting pretty bogged down with outputs. So Control/ is just a quick way of commenting code. And you can Control/ to uncomment commented code as well. So that's very handy to know. And you'll notice it'll say, thanks for trying Sublime Text every 100 times you hit save. I just hit cancel, but please support them if you can afford to support them. I use VS Code mostly, so I don't use Sublime Text in production or anything like that. But it is super handy for things like doing videos when you want to hard code what they call vanilla JavaScript or just handwritten JavaScript, as opposed to just building up from libraries like React or frameworks or like Angular or Vue.js, all kinds of different frameworks that attach to and use JavaScript but sort of have their own languages. Because of the way that we can reuse functions, you can basically create a language out of the language. So that's what we're practicing here, is just getting used to all the different ways JavaScript can process itself, basically. And functions are a good way of starting out, because you can make a function that does absolutely anything, but when you listen to a tutorial and they use all that jargon like arguments, parameters, return values, functions, etc., and all that, it gets really complicated really fast. And I find, for me anyway, it took longer to learn just because of the way it was being taught with all the lingo, as opposed to learning to see which values can be manipulated and how you can move things around from one function into the other, and just practicing juggling them is sort of the key to this type of exercise, is what I'm trying to get at. So again, remember when we said with strings, which are just text values, you can add them together using the plus sign, but they won't do math on it. But this is still helpful in our console logs and stuff, because we can say, like, this is the argument that you gave our arrow function. So now when this arrow is called, this is a variable that we defined as a function using our fat arrow syntax. So that's the same thing as saying this, and it's the same thing as saying this, but we're just doing it a bit differently. Whatever value we get in, we're going to call it n. So if I give it a number, if I give it text or whatever, and then the output of this this command is going to be to just give us a console log that says this, or that gives us whatever value we put in, and then argument that you gave our arrow function. Let's give it a return value too, so you can practice seeing things properly. So I'm just going to return whatever value we put into it, and we want to log that out so that we know that our function is working. And let's just say logging out my functioning function, just to have some fun with it. Control S, Control R. Now you see logging on my function is the argument that you gave our arrow function. That's on line 59, that's this one here. So n equals logging out of my my functioning function. This part is n. This part here is n, and this part is the string that I added together with it. So good to know if you want to like identify or keep track of your variables. You can keep using console logs and function calls like this to make sure everything's working. So again, 5 is the argument that you gave your function, and you can see how that would be interesting because you can actually start automating processes by using functions. So whereas before when we were starting out, we were told what functions do and what they're useful for, but when you sit there in front of a blank screen of text, you're like, where do I start? How do I start playing with JavaScript? These are some examples of ways you can play with JavaScript by plugging functions inside of other functions, or naming them differently, or rewording them to do the same thing. That's all good practice in learning any programming language, but you can do it very easily with a text editor in a browser using JavaScript. You don't need to set up this big IDE, integrated development environment or anything to get it working. So that's really handy. Let's make, let's do shorthand. Yeah, we haven't done arrow shorthand. Actually, I'm going to show you Camel Case. So because we can't use spaces in our variable names, often with JavaScript you'll see what's called Camel Case, and that's where the second word is just capitalized, and that's another way of writing, just to make variable names more legible to the coder or anybody else who's going through your code. It's helpful. And I'm going to reuse n just so that, again, we make sure that you get an idea and sort of a feeling for what it looks like to read code that may be confusing, because oftentimes people do this where they reuse or use single letter variables, which is terrible practice. You should always use variable names that define exactly what you're doing, even if they're long-winded or whatever, because that's easiest. But to practice, it's nice to see the bad code so that you can learn to differentiate between scopes, lexical scopes. And what we're talking about with those is these curly braces between all of our functions, including the curly braces at the top here, and from our page being loaded, it includes the embedded curly braces. These are different lexical scopes of our code on our page. So a shorthand for the arrow, it can be even more abbreviated. So all of this code here can be the exact same as just saying n without the parentheses, because we only have a single value. If you had 2, then you need to put the parentheses in, and you'll see the color change to give you a visual cue that you've done something wrong. But now our short arrow function equals, arrow shorthand is a variable. Now it equals a function call that just console logs n. And if you only have one line in a fat arrow function, one of the differences, probably the only, there's 2 differences, but one of the 2 only differences of using this type of syntax to define a function is that it automatically implies a return if you only have one line. Whereas if you write a function like this, you have to explicitly say the word return in order for x to become the value of this, or sorry, for x to become the value of this function, because this sum action is going to be a function that takes this. So if that's a bit confusing, let me just show you. This arrow syntax here, this all works, but it would work exactly the same if I took out the n, and if I took out this and commented this. So what we're doing is just sort of showing you the different ways of seeing the code so that you know what's equivalent and so that it doesn't look foreign, because when you're trying to play around with code and you see different examples from different tutorials, different people are going to write their code differently. And there are so many different ways of doing the exact same thing. And it's not really helpful to only see the proper way, because most code is it's refactored after the fact. So once you write a working code, you then go back and start making those adjustments. So you turn this into this after the fact, usually. But when you're watching tutorials, they always show you like the best implementation right off the bat, but that's not generally how code is written, because it's too much mental load when you start juggling with logic and things like that. So let's play again with the timeout event, because I don't think we did enough with that. So let's make our own function called timeout event. What am I going to do with that? Always need opening and closing braces, curly braces. Let's create a function inside of it, so that when this timeout function is called, it creates a variable, and that variable is going to be another function. So again, fat arrow, open and closing curly braces, and just to make this readable, I'm going to give it a line and indent it. Now what do I want this to do? Let's just return a console log, just to help us differentiate it though. We'll say this function was created by the function given and called in the arguments of the set timeout. And then we'll throw this function into a set timeout. That way you can see kind of a little bit more of our juggling prowess. So when this function is called, it's going to create a function, and remember this variable is only valid within this scope here, except we're going to be returning it out the back. And that means that whatever we say, like if we say y equals timeout event, this y is going to be equal to whatever's returned after this is called. So when this is called, it creates a function. This function returns a value, but it's not going to call this function yet. All it's doing is creating and defining it within these curly braces, and then it's going to return the whole function. So this isn't like a variable value. It's actually the function that produces this value, and the value is, in this case, is just to run a console.log. So now y would equal the output of all of this, which is this function. So you could call y by doing this, like we call any other function. So now you sort of getting the idea of how the juggling works. Where's y? 73. Oh, but our return console should be 67. So that's line 67 up here, because we're calling it down here, but this is going to be running this function which pulls this value. You'll notice these actually aren't separate lines. It's a word wrap because I've got the browser zoomed in, so it's just for video purposes. Yeah, let's clean this up. We don't need that. Let's actually use another timer to call that. Window, or I think we can even attach it to the body. Let's play around, because remember, we haven't even used this body yet, where we created the body tag, and all it's doing is grabbing this tag from up here and putting it inside of a variable. So let's see if we can use it. I'm not even sure if you can. But body set timeout. And remember, the timeout takes two parameters. One of them is just a function, so what you want it to do when it times out. And then the other is the timer to say how much time you want to wait, and that's done in milliseconds. So it's just an integer value. So not, I don't know, maybe floating points will work too. We should try that. So timeout event, and then comma to separate your two arguments, because remember, it takes a function as one argument, Last time we did it, I think we defined the function inside of the parentheses. So this time we'll just give it a function we've already defined, because that's actually best practice. There it is. So in this set timeout, I mean, we gave it some room so that we could see, but all it's doing is giving this as one parameter. And then after the closing parentheses, that's the end of the function. You put a comma and then the number value that you want it to wait for the timeout. So let's do a shorter timeout than the other one. We'll just do 500 on this one. And let's see if that works. Oh, no, so it doesn't like it being attached to the body. So this is kind of the fun with JavaScript, is you can play around and see what can and can't be done. Oh, let's use the this. No, we'll do that in the classes. I'll make a separate video for classes. So this timeout is going to be triggered first because 500 milliseconds is sooner than 1500 milliseconds. So this call should be done first after the page loaded code will run first, and then my timeout event. Then timeout event runs this, creates this, returns this. Let's see if that worked. Line 67. This function was created by the function given called in the arguments of set timeout. So that's all this. So yeah, it worked. The output of this function is being called after 500 milliseconds, and the output of this function is just to run a console log. So it's a really convoluted way and not practically useful, but I'm going to get a little bit playful with it now. Let's let our window set timeout, just like we did before. And again, it takes a function, and it takes a timer. Let's say 750 milliseconds on this one, just to have them a little different. Now, what's happening here is timeout event is being called, but I'm not calling it. I'm not giving it parentheses. So what I'm saying is this set timeout is it's just the definition of the function, not the output of the function, to put it in other words. So I don't know how to explain that better. Yeah, with the parentheses, it actually calls and runs the instructions in the code, and without the parentheses, it just references the function to be called when your 750 milliseconds is up. If we didn't do that, what it would do is it would say, if we did it just like this, like we did up here, what it's doing is saying this value, this parameter, this can be replaced by whatever the output is. And you'll see we've output the function without the parentheses because we don't want to call it again, we just want to reference it again. If you call it again, that's going to be an infinite loop, because it's going to call this function, which calls a function as a return, and then it's going to call that function as a return and come back. Actually, it might only call it once. Anyway, we're getting ahead of ourselves. I want to show you how you can actually bundle functions together and call them like successively kind of thing. So let's make another timeout. And for this one, I'm going to make a fat arrow function. And we'll call that one 750 milliseconds too. But now, because these both have the same timers, this one will be run first. So that's important to note. And I'm going to give myself some more room just by spacing it out and indenting to show that I'm inside of this scope, these two curly braces. Now I'm going to write timeout event, and I'm going to call it and have it call itself. Because remember, the output is just a function, but it's just the definition of the function. So whatever this outputs, I can execute it or call it by adding another set of parentheses on it, because this is replaceable by all of this created function. It's like if you imagine this block replacing this entire thing. So what I'm getting in the outcome is just created function, and to call any function, you just add two parentheses. So essentially, when I call my timeout event function, I want to call it, and then I'm going to call what it produces. I'm going to call it, basically. And this is, again, sort of getting into the fun of JavaScript, where you can really just play around with, and you'll see it calls it twice. It does it the first time because I told it to, in this one. And then the second time, I just pass the value in. I'm wondering, is the 73 one even running? Yeah, it's this one that's not running. Oh no, that is. So when I call this one, it returns all of this. And when I call this one, yeah, so when I call this one, this output is actually just the created function. But when I call this, what it's actually doing is it's calling this entire thing, which then creates the function and then returns it back and then gets called. And when I call it this way, what I'm doing is, this is essentially the same as just putting it in here. But I'm putting it inside of its own function so that I can show you how the output of an output of an output of an output, like you could do this basically as many times as you wanted for as many functions as you wanted. It's not practically useful, but just knowing how you can bend around and play with the language gives you new ways to problem solve and to really think about how you're approaching any problem that you're looking to solve. So maybe just to finish off, yeah, let's make a couple easier ones just to, again, get used to the shorter syntax. As we stated before, you don't need to have separate lines for everything. You can just write it all in one line. That's still a valid function. And if you had make B, that does A and B, you could have it return A plus B. And that again is another valid function. Let's see, make C A and then have it return, let's use a method. So a method is like a function. Oops, it's not like a function, it actually is a function, but it's a function that's tied to, split. It's a function that's tied to the data type, or the class, but we'll get into classes and objects in another episode. But just to make the functions thing clear here, using the dot notation applies a function that's built in and applied to that specific data object. Now, in the case of strings, you get string manipulation methods, because instead of having programmers write all their code themselves, for basic things like string manipulation, like taking letters and making them capitals or small or lowercase, uppercase, or whatever, those are common methods or functions that everybody would want to use in all of their applications. Anyone using strings is going to want to be able to manipulate them in some way. So there are built-in functions or methods, as they're properly called, that apply themselves to data types. So numbers have their own methods, arrays have their own methods, and strings have their own methods. Split is one of those methods. What it's going to do is just, with an empty argument here, it's just going to return the value of A, every character one at a time, and then stick them all into an array, which I'll show you because we can console log those. So I just started doing some edits and I realized that my face was covering up a whole bunch of our description, so I'm just going to re-record a little piece here for our ending. You'll notice I've changed the file a bit and I've added some comments and all that, just so that when I give it to you guys out in the wild, you can get a better idea of what we talked about and went through in our code during this video session. But I'm going to get rid of my stupid face here so that you can actually see, and we'll finish up writing our curry functions. Basically, we're going to wrap a few things together just to make a point about how we can sort of trace the call stack of what we're doing with these functions that we're creating and passing into each other, and the expected outputs that we're hoping for. Hopefully we'll make it without any errors this time and without my face blocking the way. So to start off, we're just going to make a simple function that returns whatever we give it. Same thing that we've done up here, it's all the same thing. Actually, let me just save this and reload. Now we've got that. The second function we give it is going to return A plus B, so it's going to be expecting 2 arguments this time for the second one. And we're going to make a third function called make C, just so that it's easier to follow, and it's only going to get 1 argument passed into it, but keep in mind, A and A and A, these are all separate. They're all individually contained within their own scopes, and their scopes are defined by these curly braces here. So usually you'd want to use names that are reflective of the input type that you want to get. So like a number would be like num age, so that people know that you're inputting an age when they read your code. But I'm going to do this in the complicated way, so that, or not complicated, but the less obvious way, the obtuse way, just to make it clear that we're not reusing the same variables here. We're actually, we're just identifying the fact that this function expects one thing to come in, and whatever thing that comes in, that's what we're returning. This A is only relevant to this function. And again, this is no different from having the function separated onto separate lines like this, but I just want to get you used to seeing functions in different ways, because often we'll write a function inline if it's only doing one thing like this. And even though it sounds simple, why don't we just write, whatever the value is when we use the function? The reason being is because you can just throw in the word instead of using the data value itself. And that kind of makes it easier to read code later on, because you might have a function that says multiply, add first and last name might be the name of the function. And the words make it more obvious than using variables like a person dot first name dot last name or something like that combined. So it's just easier to use words sometimes when you're working through code logic, and oftentimes you'll just have a single line function to do that. So our C is going to we're going to use an array method on this one, actually. So array, I think that's what I did the first time when I had my face covering everything. So split is just a method that's attached to array. What it does is, or attached to strings, I mean. So a string is just a variable of text, and split is built into all text variables. It's just part of the programming language. It's a method, which is a function that applies to whatever this dot notation comes through. So you can look up the string methods if you want to find out there's a whole bunch of them. And they're great practice and great to use, and maybe we'll do that in another lecture. We'll go through how to look up documentation, find a new method, and then go to our practice page and start playing around with it like we're doing here. But for now, I'm just going to show you how a string gets split into a bunch of other arrays. Or into one array, I mean, of a bunch of different characters that are comprised of the string. So we're splitting it. We could use like a comma if you had comma separated values, and that's super helpful if you're importing something like a CSV file, which is just like an Excel table, but in CSV means comma separated value. That specific syntax means that if you use split, you'll get an array, and it'll cut out the comma, and you get just the data values, and then you can start manipulating the array with data that you imported from another file, which is very useful. So we're going to nest some functions together, and this is the part that was covered up on my head before, so apologize for that, but maybe I'll edit out some of it and just redo it here. So make C is going to expect a single string, and we want to make sure that it's a string. So usually you'd name this something like str and then whatever the type of data that you're expecting, just to make it more readable. But again, I'm just using these same variables to reinforce the fact that these are within their own scopes. So this doesn't affect the A in this, and this doesn't affect the A in this. This A only applies to this function, this A and B only apply to this same function, and this A only applies to this function. And that's why we can reuse the variables without them tripping on top of each other. So inside of make C, we're going to give it 2 arguments. No, it only gets 1, sorry. Make C gets 1 argument, and that's why I'm going to use make B as its argument. So whatever the output of make B is, that's going to be the value of make C, and then make C is going to split that string, whatever we get, into, actually I'll take that out, into every character of the string. So if my name Kris, K-R-I-S, it would split it into an array. First index would be K, second index would be R, third index would be I, fourth index would be S. But B requires 2 inputs. Now I'm going to give one input to B as the output value of make A, and another input to B as another output value of make A. And in there we can just say, I don't know, testing. And the second one will be using the same function to produce another output. Could be anything you want. This is just for practice, but I'm just showing you that make A will produce a different result, a different answer. It'll return a different value. Those are all different ways of saying the same thing. Whatever you put in, that's what it spits out. What I'm putting in is testing the first time. The second time I'm putting in this huge long string. And make B will take whatever two things that you give it, even if it's a function and a function. It'll take the output values of those functions because we're calling them using those parentheses, as we did before. And then we just have to console log our nested functions to see that everything worked out properly. And hopefully we got no errors. This one. So our console log should be line 99, which is right here. And you'll notice our console log outputs every single one of the characters, including the spaces, because I put no spaces in here, into its own index array. And those are just the same arrays as we used before, and arrays have their own prototypes too, which are really fun to use. I'm going to do a whole episode just on array prototypes. But the important thing about all this is to see how we got this result from the code that we wrote. And that's by using make C, which takes one value and splitting it into a whole bunch of array elements, with each character being its own element in the array. And we do that by giving it one value, and that one value is the result of make B. Make B is this whole portion here. Make B takes in two values, an A and a B in this case, and then it adds them together. So with strings, remember, it's not the same as with a number type. The string type will just concatenate. It'll take the first testing, and it'll add using the same function as its second string. So if I used a number, it would default back to string because the order of building data type starts from Boolean to number to string text. So hopefully that makes sense. Our output values here are based on this function return. Make B takes in two values, and those two values we got are separated by commas. So that's the first value and the second value here. And it's the output of function A that becomes the parameter for function B. And then when function C, make C, calls make B, which is our main function here, we're saying nested functions is a variable that equals whatever the output is of make C. And make C is all of this, which is these two strings added together, and then split into an array. Now we could split these by spaces if we want to, and we'll get a different answer from that. Again, just Control S, Control Save. And now you'll notice my array is actually breaking up each element by the spaces between them. So the spaces between the words, and now I have way fewer elements in my array, but you can see it does the exact same thing as we expected from before. Our output of nested functions is now an array that we can manipulate and play with. For example, we can take nested functions.sort, and we can console log that too. So you'll notice now that we've got the same array twice, but this time we've got it that's actually a really good point to notice. See, the sort method changes the array itself. And then after it's computed, you can see this value is evaluated upon first expanding. It may have changed since then. So you got to be also careful with the types of methods you're going to use, because they're also going to change the outputs that you get if you're reusing the same variables. So a better way to do this might be to say let x equal nested functions, and then let y equal nested functions dot sort. That way we're assigning it first before we change it with the method that we call on it. Let's see if that works. There we go. So you'll notice 99. It's pretty good I re-recorded this. This is a good point of note, but we'll get into more into arrays on a separate video, but this is something important to keep in mind, is that when you use a method, the difference between a method and a function is the method is tied to the object, or the object type, or the data type, the built-in ones. And that means that they can sometimes, not always, but they can sometimes change the original. So what you want to do to avoid that type of mutation error is, as soon as you have the variable that you want, and then you want to start manipulating, assign another variable to it, and then apply a sort or something like that. That's why you'll see here in line 99, which is this one here, another function output produce same blah blah blah. So I guess what's important with this start here is to notice that the value is evaluated first upon expanding, as this little I indicates, but it may have changed since then. This is the original output it got. These are the original indexes, and then it's changed them after the fact because I've applied this sort to nested functions, and the sort always changes the original array. So it's best to first assign it to something else, and then say x.sort if you want it sorted, and console log that, because then you're not affecting the original array, and you can keep using it, or the original array, and then you can keep using it as it was originally produced, as opposed to the change value that it adopted later on. So if I open all these, you will see line 99 is just our nested functions here. Oh, sorry, I have to change this. Since I'm sorting x, I can just say x. Because if I apply sort to the nested function, it changes the original nested function. But you'll see now, testing using the same function to produce, and now you've got it sorted, another function output produce, and you'll notice every time I use it after that, it's also it's already been changed from that sort method being applied to it. So being careful of when you're using these types of methods, to look up the documentation and check to make sure that that you know whether or not it returns the original string back as it was and just gives you a filtered itemized list, or if it's actually going to change the list that it's being applied to permanently. Because you may not want that action. You may want it to be sorted permanently, and that's completely fine too. But just being aware that these types of methods, these types of functions that apply to data types, such as strings or numbers or anything like that, they can, but not always, change the original input string. So hopefully this isn't too much choppiness and back and forth, and hopefully this makes a good deal of sense. But like I said, it's going to be fun to just practice and play with what you know, and yeah, keep trying to give yourself challenges and figure out new ways of mixing things up and implementing the new code and methods that you learn. So that is that. Check the links in the description for GitHub to the files that I'm using here, and with that, I will bid you good day. Pretty straightforward, but as complicated as possible at the same time. But here you'll see how methods are useful, because instead of having to write the code myself to go through every character one at a time and create an array out of it, if I wanted to play around with an array, I now have like prototype properties that are built into arrays, like length and fill and pop is really useful, map is really useful. So just by console logging your data object, you can actually see all the different methods that are attached to it, and they tell you, technically they tell you what they do, but you're probably best to check the documentation online if you want to actually know the programming technicalities and theory and process and what it actually does. Go to do a Google search on the word that you're looking for, like array prototypes, as you'll see in here, prototype array. Just look up array prototypes and have them have a proper description that way. But once you've read the documentation and you want to practice and use it, this type of code and this type of code is great practice, because it teaches your brain how to sort of juggle around all your different parameters and calls, and especially this type of thing here. If you can understand how you can use a variable name as a function that you can pass inside of another function and move them around, and challenge yourself to move them around too. That's the best practice, because then you can read code and step through it, as I keep having to do when we're going through these three here to write this one here. Basically, the process is just walking through it, and if you understand the flow and the mechanics of the language, then you're better able to step through code, and then you can give yourself little challenges like this to help you practice. To me, this is better practice than reading a textbook and memorizing jargon. The jargon's very useful, don't get me wrong, but it's mostly useful to look up so that you can learn new things and then apply them this way. Memorizing just data types and objects is dry and boring, and it doesn't really give you a visual representation of what you can and can't do, which I think is really important when you're learning code, because it's mostly about the logic and structure and syntax and things that you're trying to practice and work around, but it's also like getting your eyes and your brain familiar with reading code and following really awkward logic, because that's going to help you write better algorithms down the road, and it's going to help you debug, and it's going to help you learn faster. So hopefully this is a more fun approach than just textbook reading. Maybe not. Any advice, comments, leave it in comments below, and that should just about wrap us up. Thanks much.